Hi, my name is Gabriel Gaffney. I'm a researcher in Ulster University working on the Catchment Care project. And as part of this project, we're looking at diverting wastewater treatment works effluent from entering streams and instead using it to irrigate willow coppice plantations. So essentially what we're doing is stopping wastewater treatment works discharge from entering stream waters and using it to grow willow, which is then harvested and used as a biofuel. So today I'm talking about the chemical and biological impacts of rural point sources and how they relate to our project. So just as a background, phosphorus is typically a nutrient in shorter supply in rivers and other freshwaters. And excessive levels of phosphorus may potentially result in eutrophication. So you get things like excessive algae growth. And once the algae start to decompose, they use up the oxygen in the water, and this may essentially result in fish kills. So it has impacts on water quality, and its impacts for things like achieving the objectives of the Water Framework Directive, which aims to get all water quality of at least good status. There are two main sources of phosphorus. There's diffuse, which typically come from agricultural practices. So this is leaching from fields following the addition of fertilizer. And then point sources are typically from wastewater treatment works effluent. And this effluent is made up of human waste and detergents and trade wastes and others. Um, so, in contrast to diffuse and agricultural sources, inputs of phosphorus from wastewater treatment works are relatively constant throughout the year, and they're largely independent of rainfall. So, while diffuse pollution, it's very much dependent on, for example, high rainfall events. So, when you get high rainfall events, what you tend to find is that um, the the amount of phosphorus coming from agriculture sources increases greatly. But the counter to this is also true. So if you get low rainfall events, you're getting limited diffuse sources. But in contrast to this, uh, phosphorus from wastewater treatment works remains constant throughout the year. So even if you've got low rainfall, you're still getting the same amount of phosphorus coming from the wastewater treatment works. Um, and this is especially important in summer um, when streams are at their lowest because of low rainfall. But you're still getting the same amount of phosphorus coming from wastewater treatment works. Um, and so essentially the best strategy to reduce eutrophication and reduce excessive algal growth is to target um, wastewater treatment works and sewage P inputs from wastewater treatment works. So while it is cost productive to dilute and remove P from large-scale wastewater treatment works, this is not it's not cost productive for smaller-scale wastewater treatment work systems. These are systems with a population equivalent of less than 250 people. But one potential method to do this for small-scale wastewater treatment works is to use short rotation willow plantations. And these short rotation willow copse plantations essentially use the wastewater treatment works to irrigate the willow. And one of the reasons for using willow is that it has the occurrence of nitrogen, phosphorus, and potassium in the wastewaters are similar to the NPK requirements of willow. Um, so essentially, short rotation coppice willow plantations, they remove P and they enable the treatment to be an energy neutral process. They keep the land in production, um, and they're a potential source of income to landowners who harvest them and use the willow as a biofuel. So with this background, the aims and objectives of our project were to identify 3 sites within the Arney, Finn and Blackwater catchments. And we were looking for small-scale wastewater treatment works that had a population equivalent of less than 250 people. And we were looking for wastewater treatment works that were in need of remediation and that had nearby land obtainable. So based on this, we aim to set up 3 trial sites to assess the potential of short rotation willow copse plantations to attenuate P and other pollutants from wastewater treatment works discharges. So as I say, we were looking at 3 catchments, the Finn, the Arnie and the Blackwater. We were looking for 3 sites within them catchments. So in terms of the Finn catchment, just in terms of site selection, there are 10 in-service wastewater treatment works in the Finn catchment. And of those, 6 have a population equivalent of less than 250 people. And then looking at Google Earth, and looking at the land surrounding the wastewater treatment works, we identified 4 sites that were potentially suitable for our project. So I conducted a site recce at 4 of these sites. And of these 4, we identified 2 sites, the Liscooley housing scheme and Dunnyloop housing scheme, that were potentially suitable for our project. But we had difficulty in securing interested landowners at the Dunnyloop housing scheme. But we managed to secure land at Liscooley, so that's one site that we've up and running. In terms of site selection at the Blackwater catchment, there are 79 in-service wastewater treatment works in the Blackwater catchment. And there you see the red dots are the wastewater treatment works occurring in Northern Ireland, whereas the yellow dots are the wastewater treatment works occurring in the south of Ireland. And because we had already secured a site in Donegal, we were looking for a site now in Northern Ireland. So there, of the 79 sites in the Blackwater catchment, there's 30 wastewater treatment works in Northern Ireland that have a population equivalent of less than 250 people. So following a site recce and a meeting with consultation with our colleagues in Northern Ireland Water, we identified 6 potential sites in the Blackwater catchment that were suitable for our project. But again, we had difficulties securing interested landowners. So we managed to secure interested landowners in wastewater, near the wastewater treatment works in Cavanagh, but we had difficulty in securing others. So yeah, Cavanagh is up and running in the Blackwater catchment. In terms of the Arnie catchment, there are 7 in-service wastewater treatment works in that catchment. And of those, 3 have a population equivalent of less than 250 people. But following consultation with our colleagues in Northern Ireland Water, we determined that none of these were in need of remediation. So essentially what we have now is we've got 2 sites up and running. We've one in Liscooley in the Finn catchment and one in Cavanagh in the Blackwater catchment. And ideally we were trying to secure 3 sites, but we're still having trouble securing interested landowners, landowners that want to grow willow on their sites for a 3rd site. So just a bit of background at the Liscooley wastewater treatment works site. As I say, this is in the Finn catchment in County Donegal. And you see, hopefully you're able to make out from the picture there, it's the wastewater treatment works in Liscooley is at the back of the Liscooley housing scheme. And this wastewater treatment works serves a population of 60 people, and it's discharging into the nearby Blairstown stream, and this stream is a tributary of the Finn River. So you see the discharge location there, which is the red arrow, and we're monitoring upstream and downstream of this discharge location. There is willow. Willow has been planted at the Liscooley site, but the discharge is still entering the stream. It's not yet been used to irrigate the willow. And there in the bottom left, you see a picture of the wastewater treatment works at Liscooley. So essentially, it's just all you're able to see really is a slab of concrete, but the wastewater treatment works is underneath that. So as I say, we're monitoring upstream and downstream of the discharge location at Liscooley. Initially, we had trouble identifying the source of the discharge location. So you see the bottom picture there, the green in the stream. That's we had to conduct eye tracing at Liscooley to identify the source of the discharge. So our monitoring is we're looking at soluble reactive phosphorus from the wastewaters, and we're doing that using auto samplers, and these take 1 sample every hour over a 24-hour period. So essentially we're getting 24 upstream samples and 24 downstream samples every time we do use the auto samplers. And to date, we've used the auto samplers maybe 6 or 7 times at Liscooley. We're also conducting biological monitoring at the Liscooley site. And this is, we're looking at the diatoms that are occurring. So with this, we've got concrete blocks placed upstream and downstream of the discharge location. And these serve as an algal growth substrate. So the algae grow on the tiles, on the concrete blocks, and then come along with the bento torch, which you see there in the bottom picture. And that gives an in situ reading of the concentrations of diatoms growing on the tiles that are positioned at the site at Liscooley. So some of the results from the SRP to date indicate that the soluble reactive phosphorus coming from the wastewater treatment works is acting as a downward pressure on the stream at Liscooley. So you see the blue in the graphs is the upstream values, and the orange is the downstream values. And essentially what we're seeing is spikes really at lunchtime, breakfast time, and evening time. So we're seeing spikes when people are at home and using the amenities. And what we found so far is that the wastewater treatment works is impacting on the water quality based on the soluble reactive phosphorus concentrations. So it's taking the status of the water from moderately polluted, it's taking the status of the water into moderately polluted and seriously polluted territory. In contrast to diatoms, we're not seeing much difference between upstream and downstream readings of the diatoms to date, but this may be related to just the lack of sunlight getting into the site. So the lack of sunlight may inhibit the growth of the algae. So and it also the concrete blocks may not have been in position long enough for the algae to grow. We're not seeing much difference between upstream and downstream. So in contrast to the SRP values, the diatoms are not really indicating what we might expect. So at Kavanagh, this site is just it's about 5 kilometers outside Armagh in the Blackwater catchment. And the wastewater treatment works is at the back of a housing estate in Kavanagh, and it's serving a population of 38 people, and it's discharging into a tributary of the River Callan. And there you see a picture of the wastewater treatment works at Kavanagh. So again, we're monitoring upstream and downstream at the site in Kavanagh. There is willow has been planted at Kavanagh, but again, the discharge is still entering into the stream, and it's not yet been used to irrigate the willow plantation at Kavanagh. So as I say, we're conducting similar monitoring methods at Kavanagh as to what we're doing at Liscooley. So we're monitoring upstream and downstream of the discharge point, and again, we're looking at the soluble reactive phosphorus using an auto sampler, and we're looking at the diatoms communities growing on concrete blocks that have again been placed upstream and downstream of the discharge location. But you see from some of the pictures there of Kavanagh, the site is, it's fairly overgrown. So again, this inhibits the growth of algae on the concrete blocks, which you may see in the results coming up. So just in terms of the SRP results, again, we found that the wastewater treatment works is having a pressure on the stream at Kavanagh, and based on the SRP values that are occurring there. And again, we're seeing spikes at lunchtime, breakfast time, and evening time, when people are at home and using the amenities in their house. So again, it's taking the water quality at Kavanagh into moderate, poor, and poor bad. It's taking it into these boundaries. And this was more evident in the most recent sampling when the stream was at its lowest to date. So again, if you look at the graph on the bottom left, you see that the blue is the upstream and the orange is the downstream. So when it was at low flow, we got a really high peak in phosphorus values occurring at the stream. So there were we were seeing values of 1.6 milligram per liter of phosphorus SRP occurring at Kavanagh, and this is well beyond the poor bad boundary of 1.042 expected at the site. 1.042 phosphorus milligrams per liter phosphorus expected at the site of Kavanagh. So yeah, it's having an extremely bad impact on the water quality there, and it's taken it into the well beyond the bad boundary. But again, in terms of the diatoms, as at Liscooly, we did not find much difference between the upstream and the downstream values. But again, this may be related to the light occurring at the site, and it's just the site may be just potentially too shaded for the algae to grow adequately. But I've tried to modify this in the most recent sampling at the site by just moving the tiles into potentially more suitable locations where the light has better access to the algae. So yeah, we should hopefully see better results of diatoms from Kavanagh in the future. So just in summary, at Liscooly and Kavanagh, the SRP values are shown to be impacting on the water quality, and to taking the water quality into moderately polluted or seriously polluted or bad status. But the diatoms, the results there are inconclusive, but that may be more related to just the lack of light getting into the site than anything else. So for future work, we aim to continue soluble reactive phosphorus and biological monitoring. So as I say, currently the wastewater treatment works discharge is still discharging into the stream, and it's not yet been used to irrigate the willow copse plantations. So we aim to continue monitoring as it is, and then once it has been used, once the wastewater treatment works discharge has been used to irrigate the willow, we aim to continue monitoring that also afterwards. Also, we hope to monitor the soil P levels again before and after the wastewater treatment works discharge has been used to irrigate the willow. So this is to investigate the potential for soil, for phosphorus to build up on the soil over the long-term period. So finally, just in terms of the transferability of our project, Ireland has over 620 wastewater treatment works with a population equivalent of less than 500, so small-scale wastewater treatment works. And Northern Ireland has over 470 wastewater treatment works that are considered small-scale. So there's and you see in the graph of Ireland there at the side, there's the potential, large potential to employ wastewater willow copse plantations throughout many of these sites. And willow copse plantations have been successfully employed at Bridgend and Drumkey and a couple of other sites for treating, wastewater treatment works discharge and landfill leachate today. So, there's the potential to employ them throughout Ireland. But as I said, we had difficulty securing interested landowners, and we've had difficulty in finalizing our third site to date. So we're hopeful to get a third site up and running, but just getting those interested landowners secured is proven to be a bit of a problem. So that's all I have for you today. So thank you. Thanks.